Hello everyone, welcome to this video where today we're going to look at how we can copy and paste our model data within an SRAM file. And throughout this video we're going to be utilizing the clone tool, and this allows us to specify translational or rotational clones of model data in order to create the geometry that we're looking for. And we can copy or clone those objects at a constant or a variable spacing. We also have the ability to copy loads, generate auto-created folders to help us organize the model. In this first example I'm going to show, we have a double howe steel truss that's 7.2 meters in span. And we're going to use a clone tool to model this. We have steel sections assigned, and we've also got some loads applied as well. We have dead, live, and wind loads applied to the model. And we're going to look at how we can use the clone tool to generate the 3D model from that 2D frame that I just showed you an image of. So I have the SRAM model opened here, and we can see the rendering of the sections and so on. It's just a 2D frame. I have section properties assigned, so these are pulled from the steel database that I'm using, and they've been assigned to various components within the model. I also have boundary conditions. Maybe I'll turn off my rendering so it's a little easier to see that we have these joints at the bottom that are fully fixed. And if I switch to the loads window, I can see that I have 3 different load cases defined: dead, live, and wind. And I'll just toggle on the display of these loads. So for the dead load, I have a 3 kilonewton per meter distributed load. Live load, I have a variety of joint loads. And the wind load, I have a projected line load as well, being applied to the areas that we can see here. Now, to help me set up this model to make sure that it retains all of the loading information that I have already defined for each one of the clones I'm going to create, we can go to the settings menu, preferences window. I'm just going to drag this to my other screen here. And we're able to see that there's this option under the interface tab that says always preserve loads during element subdivision. But below that, I want to make sure that I also have always copy loads during a paste operation, just to make sure that those loads are retained if that was my intention. So I'll check that option, click OK, and then go back to the geometry window. And here I'm going to introduce a trick. When we're working with this clone tool, it allows us to clone not only the members, but also the joints. And with the joints that we select, we can actually extrude members from those if we'd want to have members connecting each additional copy. So what I'm going to do is I'm going to actually unselect the joints that I don't want to create members between. I'll just unselect the bottom, and then along this bottom edge of the truss as well. So every other member I'm going to use or every other joint is going to have a member connecting that to the next frame over. So now that I have what I want to clone, I'm going to go with the Control-C to copy this selected objects. And now I'll use the clone tool right here. I'm just going to right-click on it. And we can see here that we have the ability to generate folders, which I'm going to do, and I'm just going to call this truss. I can choose which generation method I'd like, whether it's a rotational or translational generation. I'm going to go with translational. And I can specify how many copies of this geometry I'd like. So I'm going to say here that I have 8 copies at a spacing of, we'll go with 4 meters. And the last thing I want to do here is I want to extrude members from the selected joints. As you may remember, I've only left a few of these joints selected, and I'm going to extrude members from those. So now I can click the OK button. And we'll be able to see very quickly here that we're able to generate this 8 copies of this particular frame that we drew. And I'm just going to select the entire thing here and review some of the details. So we can see here all the section properties have been retained. We also have the loads and the supports. So I'll show you supports and the loads, which again have been copied over from the original copy. And so at this stage, I'm ready to go ahead and run an analysis on this 3D structure without much effort from my end. So I can click Analyze, run a linear static analysis, and very quickly here, we're able to see, let me just show the entire model. I won't show our loads. We're able to see things like the deflected shapes, the shear diagrams, and bending moment diagrams, and so on, that might be of importance to us when we're designing this structure. And of course, we could always make use of S-steel, since this is a steel structure. Now the next example I'm going to use is using a floor plan. So I drew a 2D floor plan that contained the location of columns and the walls and also the outline of a floor plate that will be modeled with a rigid diaphragm. And then after that, I just used the clone tool to specify the spacing I'd like to define. And I can create my 3D structure from that 2D floor plan and extrude any shells from the wall integration lines to help me define the walls and their stiffnesses. So for this example, I have another file open here. And as I mentioned already, we're using a rigid diaphragm panel to model this floor plate. I also have these joints that you can see here that are used to basically outline the location of my columns. And I'm going to copy those just like I did with that last example to generate members from those joints. I have deliberately not selected these joints around my wall outline here because I don't want to create members out of those joints. But those members are a little bit different than the ones we dealt with in the last example. The difference being is that they're modeled as wall integration lines. Now we have plenty of content and learning material about wall integration lines, so I'm not going to go into detail, but these are basically meant to be used to extract forces from 2D elements. They're not contributing anything to the stress stiffness matrix or contributing any mass or anything like that. But they can actually be utilized during the clone tool operation to generate things like shell elements. And I'll show you what I mean by that. So I can hit the Control-C button to copy this geometry. Then I'm going to go and use the clone tool. And this time around, I'm going to generate folders, but this time I'll keep the default folder base name level. So for my generation method here, I'm going to stick with translation, but it's going to go in the Z-axis being the vertical axis here. So I'll say that the first floor is going to be 4.5 meters. It's a little bit taller than the other floors behind it. And I'll make another 8 floors, and they'll have a dimension of 3.5 meters. And I will extrude the members from the selected joints to create my columns. And I will also extrude quadrilateral elements from my selected wall lines. And I can choose how many elements I'm going to create along the longest wall line. So you can see here we've got a wall line here that spans the back of this core wall. So I'll say that we have 6 elements along that line. And along the longest edge here, I'll say that, or along the largest increment, I'll say that I have 5 elements. So the longest distance between our spacing. And finally, I have the thickness of my shells, which I'll say is equal to 300 millimeters. Now I'm going to click OK and start generating these clones, and you'll be able to see very quickly what we end up with. So let me just select the entire structure here. I'll turn off the display of my coordinate systems, and we can see that we're generating a 3D structure that has shell elements representative of the thickness of the wall that I defined. Of course, I haven't gone into much detail about the material properties or the loads or anything like that here, but I just wanted to show you the workflow. But it allows us to create these 3D structures very easily without having to go through the tedious process of defining each floor one by one. And of course, the model is separated into folders, just like in that last example. So we can see here we have level 1, we have level 2, and we can isolate any one of these selections and view the information in more detail for that one specific component. And of course, if we want to view our structure in more richer graphical detail, we can use SView. So I can use SView and look at the object view, and it will give me a better understanding for what this structure looks like once it's actually been constructed. And this is showing me the view that I can use the perspective projection, or I can use the orthogonal projection depending on my own preference.